As wireless technologies evolved, our world has become more and more connected since the first generation of wireless technology. 1G connected us through mobile phone calls, 2G lets us text for the first time, 3G connected our mobiles to the internet, and 4G gave us the reliable connections we have today. However, as 4G has started to reach its peak capacity due to the increasing amount of users and the Internet of Things revolution, 5G has emerged as to overcome the limitations of previous generations. 5G is not just a mobile device or a technology. Instead, it is the backbone that will lead to various applications such as virtual reality, smart cities, smart homes, autonomous driving, and much more that has yet to be discovered. 5G utilizes an unused high radio frequency spectrum in addition to the radio frequency spectrum that is currently being used by 4G LTE. This is so that it can handle up to 10,000 times more traffic than the current network. What this means is that there is a greater bandwidth to accommodate large number of devices, low latency less than 1 millisecond, and better speeds of up to 10 gigabytes per second, which is actually 10 times faster than the current 4G. In this video, we will talk about the implementation of 5G in Internet of Things, focusing on its application layer and some real-life use cases of these implementations. The Internet of Things refers to the interaction and communication between billions of devices, providing the ability to share information related to real-world subjects through a unified framework. It is achieved by seamless, ubiquitous sensing, data analytics, and information representation with cloud computing as a unifying framework. Common technologies that enables IoT applications are radio frequency identification and wireless sensor networks, which are low power and easier to implement. There are different types of IoT that can be applied through the use of 5G. For example, the first one, machine-to-machine communication. It is the dominant discourse used by IoT, which involves peer-to-peer communication. Another example is massive machine-type communication, also known as massive IoT. MMTC pertains to services that usually span massive numbers of devices, generally sensors and actuators. These are latency-tolerant systems, and the individual data generated is minute and can be applied on low bandwidth and lossy pipes. And finally, there is the critical machine-type communication, refers to applications such as unmanned robotic surgeries, driverless cars, automated transit system, control of critical infrastructure for industrial process. The reliability and precision requirements of such services are huge and indispensable. Today, we will look at some of the requirements and network architecture in the 5G application layer that is used for application and optimization of the IoT network.